Welcome, my dear students. This is the second video of our channel. In this video, we are going to present first theorem of 10th standard. It is called Thales theorem. It is also called as basic proportionality theorem. You know, theorem is a mathematical proposition which can be proved logically. Theorem has two parts: hypothesis, what is to be assumed; conclusion, what is to be proved. Identification of hypothesis and conclusion is first step of proving a theorem. Next step is diagram, pictorial representation of hypothesis. Next step is data, description of the diagram drawn. To prove conclusion part of the theorem written with respect to the diagram. Construction. In this theorem, construction is required. Proof. You know, proof is nothing but putting known things in a psychological order to reach unknown fact. Here, known things required to prove Thales theorem is: number one, area of a triangle is equal to half into base into height. Another 9th standard theorem, that is triangles standing on the same base between the same parallels are equal in area. Now let us take up the proof of this theorem. Statement of the theorem is: Thales theorem states that if a line is drawn parallel to any side of a triangle, then it divides other two sides proportionally. Here, hypothesis is a line is drawn parallel to any side of a triangle. Conclusion is it divides other two sides proportionally. Thales theorem states that if a line is drawn parallel to any side of a triangle, then it divides other two sides proportionally. In this statement, a line is drawn parallel to any side of a triangle is hypothesis. Conclusion here is it divides other. Diagram is pictorial representation of hypothesis. In this theorem, hypothesis is a line is drawn parallel to any side of a triangle. Therefore, I have written the diagram of a triangle ABC. In this triangle, PQ line is drawn parallel to BC. Therefore, here diagram is ABC is a triangle in which PQ parallel to BC. Next step is data, that is description of the diagram drawn. Description of the diagram drawn is data. Here data is in triangle ABC, PQ parallel to BC. This is data. Next step is to prove, that is conclusion part of the theorem written with respect to the diagram drawn. Here conclusion part is it divides other two sides proportionally. Therefore, to prove is PQ divides side AB and side AC proportionally. That means in equal ratio. Therefore, we write AP over PB is equal to AQ over QC. That is to prove. We have to prove AP over PB equal to AQ over QC. Next step is construction. Here construction is required. Construction here is join PQ and PC, draw PM perpendicular to AC and draw QN perpendicular to AB. This is because we take triangle APQ and AP as a base and hence QN becomes height. For another triangle PBQ, PB becomes base and height is same QN. Similarly, if I take area of triangle APQ and AQ as a base, height becomes PM, and if we take QC as a base, height is same PM. For that reason, we have taken height QN drawn perpendicular to AB and another height PM drawn perpendicular to AC. This is the construction required. So we have to write same thing in construction. That is join BQ and CP, draw PM perpendicular to AC, QN perpendicular to AB. Next step and a beautiful step is proof, that is linking known to unknown. In the proof, see my dear students how mathematician linked the known things to reach unknown fact. Here area triangle APQ over area triangle PBQ is equal to half into base AP into height QN whole over half into base PB into height QN. Since half cancels and QN cancels, therefore we left with area triangle APQ over area triangle PBQ is equal to AP over PB. We make it as equation 1. After equation 1, we take once again area triangle APQ over area triangle QCP. Here in triangle APQ, we take AQ as a base, therefore height becomes PM, and in triangle QCP, we take QC as a base and hence height becomes PM itself. Therefore, area triangle APQ over area triangle QCP is equal to half into base AQ into height PM over half into base QC into height PM. Therefore, half cancels, PM cancel. Therefore, area triangle APQ over area triangle QCP is equal to AQ over QC. This becomes equation 2. From 1 and 2, AP over PB becomes equal to AQ over QC because area triangle APQ, numerator of first equation, and area triangle APQ, numerator of second equation, they are equal, and area triangle PBQ, denominator of first equation, and area of triangle QCP, denominator of second equation, they are equal because these two triangles are standing on the same base between the same parallel are equal in area. Therefore, left hand sides of first and two are equal, and therefore right hand sides are also equal, which is according to mathematical axiom, that is, things which are equal to the same thing are equal to one another, and hence AP over PB become equal to AQ over QC. Therefore, according to Thales theorem, if a line is drawn parallel to any side of a triangle, then it divides other two sides proportionally. It is proved. Thank you very much. Let us prove the next theorem, that is converse Thales theorem, in the next video.